Hi everyone, I'm Dave, welcome back to Goodford Model Railway. The following video I started making probably 6 to 8 weeks ago maybe. So this is just a combination of what I've achieved over the time. I've done quite a lot in between, but this video is on the electrics. So in this video it does get a bit complicated. I confused myself a few times whilst filming it, just because it's been a while since I've done the electrics on a layout, but it's relatively straightforward once you've done a few bits. There's a lot of repetition in it, which is why it's one of the jobs that I dislike more than others, shall we say. But yeah, so this video will cover the control system I use, the electrics, how I do all the points, how I do semi-automation, with quite a large section at the end on ABC braking. So if that's of interest to you and how I semi-automate a layout, then please stick with it. It's quite an interesting video, shall we say, from the point of view of it covers a lot of different aspects of the electrics. Any questions you've got, feel free to comment on the video. But yeah, here's handing back over to me a couple of months ago. Thanks. So starting off here, we've got the Z21 DCC system, and due to the size of layout, I've introduced 2 dual boosters. So that just gives me 5 separate outputs, each capable of 3 amps. It's possibly overkill, but I'd rather have planned it with too many rather than not enough. So that's all run by, I won't go into too much detail, but it's all run by an app which I've got linked into an iPad, and that also allows you to do, I haven't done the track plan yet, that's my last one, but you can do all the points and everything on there. So that's the main control system that I'm using. Then the 5 outputs then run down the side of the room to this little connection block here. It's just so that it was easier for me to set up the separate bus. So you can see we've got 5 different bus connections there, plus the programming track. So I'll put the programming track up the top here, so that's the one closest to me, and then I've got a separately connected ESU Lokprogrammer, which plugs straight into my laptop here. So I can do everything that I need to do to locos and setting them up, making changes using these 2 tracks here. The 5 bus wires then run underneath here and then into the layout. So the actual bus wires, I've run 5 sets at different points of the layout. So it's just connected up using the wires that I showed you before, and then they run all the way down the layout. So you can see one pair of bus wires there, and then you can see another one pair just behind there. So there's 5 sets of bus wires on the layout. These bus wires are then run to the track. So you can see here the inner and outer. Something I did need to be mindful of is if we look at the wires going up to the tracks. So I've tried to keep black as the outer rail. So we've got black wires as the outer rail and white as the non-outer rail. But because the layout runs around the corner like this, then it means that this rail here, sorry, this one here is black and that one's white. So it means that underneath you've got 2 rails there. So that rail is then that rail on this side over here. So it's a bit of the black is on the right hand side for these 2 bus wires, and then I've got 2 bus wires for the fiddle yard, and the black is on the left hand side. So it's just making sure that I get the colours and the rails the right way around. It's the first time I've done a layout that sort of loops back on itself with separate bus wires. So I don't necessarily believe in running a connection to the rails to the bus wire at every single fish plate. I think that's massively overkill. But this section here, because the extent of it is around 28 foot roughly, I think, up to this point here, which is where it changes, goes all the way down. I have run a few extra power feeds into this track because there's a batten underneath on the far track. I've run it to the track closest to the camera, so this track, and then I've just run a couple connections behind on the fish plates. This is all going to be covered permanently. This gap here is just so that I can reach up to clean it, so yeah, that's never going to be on display. Yeah. The other consideration that I had when doing the power feeds is ABC braking, but I'll come on to that a little bit later in this video, but I wanted to explain where I'd put the power feeds and why. So I run ABC brake on the left hand rail, which means there'll be a cut in the left hand rail towards the end of a passing loop. So you can see this is the start of a passing loop running in that direction. So I've just put the power feeds on the left, right at this end of the loop, and then running all the way around, I've done the right hand rail feeds at this end of the loops. So it allows me to cut the left hand rail wherever it needs to be, so I can put the ABC braking module exactly where it needs to go without having to move feeds around, etc. So what we're looking at here is just a random point in the fiddle yard, and I just wanted to run through the basics of the types of points I'm using. So they're all Pico electrofrog points, code 75 fine scale. So electrofrog essentially means that this frog here, this bit here, is all connected electrically. So all of that metal there that I can see, including the blades, is connected. It therefore means that if a train's running in that direction, then the frog will be the left-hand rail. If a train's running that way, it'll be the right-hand rail. So the way around this is you can rely on the connection here. So when that point is switched and the blade is touching the right-hand rail, it means all of that is then connected to the right-hand rail, so it's fine for running in that direction. The potential issue, and the reason why I picked this point, is because over time they get dirty. This point's probably been on another couple of layouts in the past. It's a bit dirty. The connection here isn't always going to be perfect. You can see the dirt behind there. So you can't always rely on that connection there to power this bit of the point. This is isolated here, so got isolated fish plates there. So the way of connecting this is via the wire that is already attached when you buy it, that goes through the bottom. So I've cut a hole through there, and that goes through the bottom. And the best way of doing this is to use a frog juicer. So let me just show you how that's connected. So now we're under the layout where that point was. So here you can see from another point the bit of metal that I mentioned that sticks out of the point. So that is out of a different one. So the point we looked at, that bit of metal sticking out is actually connected to this bit of kit here, which is called a frog juicer. Cost about a £5, quite easy to come by. So that's connected, soldered into the middle underneath there. And then you've got two more connections running to each of the bus wires. Doesn't matter which way around they go. And as soon as a loco train hits that point, then it will automatically switch the polarity of the frog to one of your two rails, depending on which direction it needs it to be in. And that's it. It's simple, it's done. It's not then relying on the point blades to pick up the power. Just a little hint, if you're going to install a lot of frog juicers, then turn the power on every sort of 5 or 6 that you install. If it's on one bus wire, I tried to install 20 odd on one bus, and yeah, it kept tripping out. I wasn't sure why, and then I realised that they're all trying to switch at once and there wasn't enough power to do so. So yeah, just limit it to sort of 5 or 6 at a time, switch the power on, double check everything's working, and then do some more. It helps problem solving then as well. So yeah, just a little hint. The next thing I wanted to show you is how I control the train. So this is the primary controller that I use. So as you've seen, I use the Z21 system, and this comes with a very, very good app which can be installed on your phone or a tablet. Being an Apple user, I have it installed on my iPhone, but I don't really use that. I just use an iPad, which is what you can see in front of you. Now, the beauty of it, I'm not going to run through a huge amount of detail, but you don't have to remember numbers for any sort of functions on locos. You can use language, so that is programmed into 3 or 4 or something. All of this is customizable. You can have 3 different screens here, and everything is done through the actual what it looks like, rather than having to remember anything. So if someone like me with not the best memory in the world, it's easy to use because it's quite intuitive. It's quite easy to set things up to run at scale speed. You can see up there, it's got miles an hour, and you can run things at scale speed. The main thing of what I wanted to show you today is the actual track plan. So on the right hand side of the screen, you can see the track plan. So this took a few hours to do, to put together. It's not that easy to do. It'd be great if there was a way of doing it through the web or through something other than an app. It's not ideal. As you can see, there's a lot of sort of squiggly bits in it, and I know it's meant to be a block diagram, but the way I set it up is to try and get things as straight as possible and to replicate what you can actually see in front of you. So this up here is a small station which we're calling Oakley. This down here is the main station which we're calling Goodford. We've got a fiddle yard here which is hidden down one side, fiddle yard up the top there, and then that's the sort of hidden goods depot, and we've got loco sidings down there. So everything's on here. The blobs, as I call them, are route setting. So this brings me on to the next thing that I wanted to show you. So ultimately, I have, for example, on this fiddle yard track at the top here, I have one there and one after as well. So what I will show you after this clip is ABC braking and how I utilise it. But I wanted to show you the track plan first, because you can see on here we've got one blob there which I label stop. You probably can't see what's written under it, but I know that the one at the left means stop, the one on the right means through. So what that means is if I want to stop something in this top fiddle yard track, if I hit the stop route planner, it will do all the points beforehand and stop it at the end of that fiddle yard track. If I just want to run it through the track, then I hit the through blob, and then it runs all the way through. So if I hit that one there, run all the way through. So it won't actually work now because it's not switched on. So we'll just switch it on. So I hit that one there, and then you can see it will change to green to see it running round. If I wanted to stop something in there, then it changed to black again. So next I'll show you ABC braking and how I use it and why what I've got set up here is so important. So I've mentioned this quite a lot, ABC braking. So what you can see in front of you is an ABC braking module, which is essentially 5 diodes, all arranged in series, and they go across a connection. So the principle is that this dual connection here goes across a gap in the track. Okay. So a gap in the track, I mean, for example, I've cut one there. You see where the mark is? There's a gap in that rail. I've set all my ABC braking up on the left-hand rail. Doesn't matter whether you do left or right, it just happens I'm doing the left. So that means that this bit of rail here is isolated from the rest of the track, because there's also another gap at the other end, which is actually a part of Yeah, you can see an insulated fish plate there, roughly. Yep. So that means that rail there is isolated. Looking at the module again, if you connect those two across one of the joins, so I connect this wire here across one of the joins, it means that when a train enters that section, it is dictated by this module here, the ABC braking module. You can set up your distance of how far you want it to go before it stops using a Lokprogrammer. You can see here I've set this one up to 96 as the distance. So there's a predetermined distance that I want everything to stop in. What's this distance on my layout? Well, it's around 3 foot, I think, actually. Yeah, probably around 3 foot. You can see just there's a black mark on this piece of string. So that is where the front of every loco will stop, based on the ABC braking module being at that point there. So every loco that I have is set up to stop within that distance. Irrespective of how fast it enters that section, it will always stop where that black mark is. So how do I work out where to put stuff, where to put the brakes? Well, just work out where you want it to stop on that loop or that siding, and just use your bit of string, work your way back, mark where it is, and do the cut. Quite simple. So once the train's stopped at the end, how do you get it to start again? Well, you override it. So the way of overriding the module is to short across those two. Okay, shorting sounds like it's dangerous, but all you're doing is putting a wire across there, so there's less resistance, and the AC circuit goes in both directions rather than it only going in one direction. Okay, so the AC current will go both directions again when you short across that, because the diodes aren't preventing it going in one direction. Okay, so therefore the track is essentially made again, or it's connected again. So how do I do this? I use a relay. So this board here is a relay board. It's a double relay, so it will be across one or the other. Okay, so the way I have this set up is that's the center of the relay, if you like, the center of the relay switch, and then you have one going to one module, ABC braking module, and the other output going to the other ABC braking module. So it means that this relay, switch one way or the other, it means that one of these ABC braking modules will be active. Okay, this wire here goes to the track. So when it's connected, okay, then it means that that's going to the track. So it means that this wire here, so number 1 on there, as you can see, is going to the track, and this one here goes to the section of the track that you're bridging, and then it goes to that side of the switch, so that when that switch bridges that gap, then it will bridge the gap across these two here. Okay, so the gap is bridged on one module or the other. Why do I do that? Because if we go back to the track plan again, I will use, for this top bit here, so it keeps going out of focus, for those two tracks there, I will use that end point to do the opposite. So only one of those will be through and one will be stopping. Okay, so it's a bit of a fail-safe essentially. So if that point there is against the through track, then it will stop before the point in the predetermined distance that I showed you a second ago, and it will always stop within that point. So I'll use that point for the top two, I'll use this point here for these bottom two here, and so on. and you can choose which point you use. You can get a bit clever with it and use multiple points if you want to block off 3 out of the 4 tracks. In my experience, you don't need to, because what goes in is controlled by what's here, and you just have to remember after something's stopped to switch it off on here. Okay, so let me do a little demo. So this is the section of track that I showed you with everything in place. Here's one I made earlier if you like. Okay, so you can see the 2 modules which are connected above to the 2 rails. You can see the switch, so that's the relay switch, the 2 modules, and then they are connected to one of these which I use to control the point motors. So the point motor that does those far 2 tracks is this one here, and that is connected to here, and then you can see 2 wires coming out of each of those modules, and that goes to switch over the relay. Okay, and that's it. And then to complete that circuit, you've got this extra wire, which, as I said, goes to the bus wire for the left-hand rail. So therefore, when the relay switches, it will bridge the gap against one of the ABC modules. So I've started the 57 running round, and as you can see at the top here, that is set to go through. So if I now hit the stop button, so you hear that ping across. So that point there, I switch back. As you can see, that point there is now going against this top siding. Okay, so what will happen now, where is the module where I'm marked? So what will happen now, you can see there's a break in the track there. As soon as the loco hits that break in the track there, then it will begin to stop, and in theory, and in practice, I should imagine, hopefully, it will stop where I've marked just there. Okay, so let's wait for it to come round. So I've turned the sound off for the purpose of this video, just so you can hear me, I'm afraid. So now when it hits this section here, it will begin to slow down. And stops at the end of the siding. That just so happens, not that I plan these things, but that is exactly the right length for that siding. Okay, so now that is stopped there, the power is still on, I'm still running at 40 miles an hour. Now, again, in theory / practice, if I change that to going again, and you can see, just flip the point back and the train starts to move again. I haven't done anything other than flip the point. And you see the train's off again, and it will keep running through now until I flip that point back, and then it will stop in exactly the same place again, regardless of what speed it was going. If you want to get really smart with the ABC braking, then you can set up a shuttle. So on my layout, there is a single line here, which runs independently of the main line, I might add. So I can leave it running automatically. It just runs around to there. I did consider and trial running it into a small station here, but it just didn't quite work. It made the small station feel bigger than it needed to be, so it just terminates at the end here. So to set this up, it's a lot simpler than what I've just explained with the points. You literally just need one module either end. So there's a break there with the module across there. Let me just duck underneath and show you. So there's just one module there, and then there's another break on the left-hand rail. Where is it? Around there, and there's there. Okay. So if I start this up, I've got it set up to do 30 miles an hour. It's 158. So I've set this up. I've done all the sounds on it. so that the doors and everything open up. And if it will work properly this time around, so I've started it halfway through a cycle, but it'll run in here. I've set all the sounds up so that the doors open and shut, and then the whistle goes off, and then it moves off again. So you can see that it stops there, and then should wait for a sec, and then the doors will open. Famous last words. And it's just a bit of trial and error with regards to setting up the timings of it. And then go to see the door opening light, and you can see the sound going off. So if I just show you quickly the setup on the Lokprogrammer quickly. So I've just enabled ABC shuttle stop, and then if we go to the function settings, you can see I've got a lot of random sounds set up with specific timings on them. 149, not sure what that's for. Yep. So let's just jump back and see it leaving the station. You can see one of the random sounds there is one of the air conditioning units going off. But hopefully in a sec the doors will shut and it will depart. The only issue I've got at the moment is when it gets to the other end, the sounds are still on. So I tend to just run it when I'm running other stuff with the sound and everything else switched off. I have managed to work out or toy with the idea of fading out the sound, so setting up the sound fade out as a random function. But it just means that every time I switch on the layout, it resets. So therefore, by going to the other station, actually it did sort of eliminate that issue. But I just want to try and keep things as simple as possible, and I don't want to have to start trying to use iTrain or anything like that to automate things. I want it to be, once it's plumbed in, then you just leave it and it runs. So there you can see the timing's been set up to door shut, whistle goes, and then it departs. And I've done nothing other than leaving. As you see, that's still set on 30 miles an hour. So it will now run round to the other end of this loop. I'll just scoot over there quickly. As soon as it hits this brake in the left-hand rail again, it will exercise the same process and stop just before the buffers. Famous last words. Here we go. That will stop there. And that's it. And it just runs back and forth continuously until I turn the power off. And here I am again. So thanks very much for watching that. As I say, if you've got any questions, please feel free to drop me a comment on YouTube. I'm not on socials or anything with this layout, but always quite active on YouTube. So any comments you've got or questions, or you want to reach out to me, then drop me a little comment on the video. But yeah, thanks very much for watching, and I will be back soon, hopefully with some interesting and exciting scenery updates. So yeah, see you soon. Thanks.